on this. All right, so the first thing we're going to do is we're going to graph this equation here, 3x plus y equals 5. Now, I'm going to do method 2 first. There's 3 methods for how I'm going to teach this. I'll go ahead and say some are easier than others. Do y'all know what slope-intercept form is? You know how to write it, like what the equation is for slope-intercept form? Oh my goodness, y'all remember something. Y equals mx plus b, good. What's the key characteristic about this equation? Think about like this equation. What's the key thing? Y is by itself, right? So what you want to do to get it, to do it slope-intercept form, graph using slope-intercept form, we have to get y by itself here first. This is light work. I want to get y by itself. So what do I do to get y by itself? What needs to move? 3x. How do I move 3x? Minus 3x. Now, when you rewrite this, put the x part first and the number part last. Y equals negative 3x plus 5. And so that's in slope-intercept form. Y'all are going to be money on this, okay? I would say for lines, I'm skipping ahead. I would stick to these 2 methods, and I'll try to explain. This method is not this method's a little too time consuming for this method, but you'll use this for higher order functions and polynomials, okay? But I would stick to these 2 for now, for today. That's my advice. You'll get to pick however you want to do it. Now, when you do this, now you've got to identify the slope, which is m, and the y-intercept, which is b. What's the slope of this equation? Negative 3. The slope is the number in front of x. They call that the coefficient. And what's the y-intercept? 5. Now, before I go any further, I want to make my slope into a fraction. How do I make this into a fraction? What do I put over? 1. Y'all are so smart. Y'all are killing it today. Y'all are actually talking today, too? Good job. Now, slope, we're going to talk more about that in a moment. On a graph, y'all know what it means on a graph? Rise over run. I heard somebody say it. Rise over run, okay? So rise over run. All right, that's what the slope means. Now, when you start the graph, do you start with M or B? Do y'all remember? You start with B. Okay, B, we start with this. So we start with this. B is the y-intercept. What does a y-intercept mean? Don't think too hard. Yeah, where it crosses or touches the y-axis. So where's this going to cross or touch the y-axis? Good. Y'all are going to cook on this. Y'all done this before. This is going to be light work for y'all. Okay? And then from this point, we will apply the slope. So from this point, what's my rise going to be? What's my rise? Negative 3. So that means, do I go up 3 or down 3? Down 3. And then my run's 1. So if it's a positive, I go on the right. If it's negative, I go to the left. So it's positive. So positive 1. And there's my second point. I could do it again if I want, but you only need 2 points here. So go down 3 over 1. And so there's your line. Okay? So that's how to do it using slope-intercept form. You have to get y by itself if it's not already, and then do that. Okay? So that's how you do slope-intercept form. I'm going to let you, what basically my philosophy is going to be, I'm going to want y'all to choose between B and C throughout the class on which one's easier. You could do this way every time, but you could also do this way. Okay? All right. Now we're going to do the intercept method. I'm going to do C next. All right, the intercept method, this is good when y is not by itself. This is the way I would use it when y is not by itself. Okay? This one is good when y is by itself. So I would use this one when y is by itself. I would use this one when y is not by itself. Okay? All right? This way, I really like this way. I think it's actually pretty easy. This is a completely different way to graph than this one, so keep that in mind. So I'm going to find the x-intercept. Okay, now let's talk about the x-intercept. What is the coordinate of this point? I'm at 1 on the x-axis. Do you know what that is? 1, 0, right? What's the coordinate when I'm at 3? 3, 0. What about when I'm at negative 4? What's true in all those points? 0's what? Good job. So guess what? To find the x-intercept, just make y equals 0. So to find the x-intercept, make y equal 0. That's all you got to do to find the x-intercept. This is light work, okay? Corbin Dobbs could probably do this, right, Loudon? Probably not. So you just make y equal 0 and just solve for x. That's all you got to do. And you could even cover up the y. I've seen some teachers say just cover up the y. So just to find the x-intercept, make y equal 0. Okay, so that just goes away. Then how do I get x by itself? Divide by 3. So the x-intercept is 5/3. The x-intercept is 5/3. So it's going to cross or touch the x-axis at 5/3. That was a poorly drawn graph there, by the way. So it's like 5/3 is 1 2/3. So it's about right there. I didn't do that graph very well. So sorry, Miss Demon Slayer. To find the x-intercept, you make y equal 0. Take a wild guess. How do you think I'll find the y-intercept? Oh my goodness. And I'll pause here for a moment. Anytime I'm on the y-axis, x is 0. Okay? I think this way it does. I just want y'all to pick the easiest way, okay? So Frankie's going to have one of these to do on the test. And so I want Frankie to, and the y is not going to be by itself. So I want, if Frankie wants to get y by itself and do this, that's perfectly fine. If Frankie doesn't want to get y by itself, he can do this way, and it's perfectly fine. So I want him to choose whatever way he wants to. So I'm going to plug in 0 for x. So 3 times 0 plus y equals 5. You see this just kind of goes away. So what's the y-intercept going to be? Y-intercept's 5. So it's going to cross the y-axis at 5. So there's my line. You see it's the same line. Okay. So you see that's the same. I would stick to these two. This way always worked. This way is too time consuming. I'm too lazy to do this way. I'll teach it, but I would. Now, if Frankie wanted to do it this way, I'm not going to stop him. But I'm too lazy to do this way. It's too time consuming. I'm only going to do. So on this one, to do points, you pick any values of x you want. What are the easiest values of x? I'm not going to do all these. I'm just going to pick 3 x's. I'm going to pick 0, 1, and 2, okay? As I said, whenever we do higher level graphs, like quadratics, cubics, all that, tables are going to be great. But for now, tables aren't very efficient. These two are, because I'm going slow here. Whenever y'all do this later, you're going to be so much faster than me. I just pick values of x, and then how do you think I find the y's? Yeah, just plug them in, right? So y equals, so -3 times 0 plus 5. You just plug in the x's. -3 times 2 plus 5. You just plug in the x's, okay? That's all you're doing here into the equation. As I said, it works, it's good, but it's not the way I would do it. -3 times 0 is 0, plus 5 is 5. I'm going to go kind of fast here because I don't Now, if Haddon wants to do it like this, that's perfectly fine. So -3 plus 5 is 2. And then -6 plus 5 is -1. This is not efficient. So Cole, I don't recommend this. But Cole's his own man. He does what he wants, though, right? Okay, so you see it's the same thing, but this is not, I don't think that's very efficient, but that's just me. So my advice, if I'm giving Frankie advice when he's doing a test, like which way should I do it? He could do it either one of these two ways, but what I would tell him is y by itself. It's y by itself, do this way. Y is not by itself, do this way. That's the easiest way to do it, but